So this morning's update is the high voltage side fooling device. This is based on an IRS2153 self-oscillating half bridge driver IC. Now, if you're familiar with any sort of basic electronics, you'll know about the 555 timer IC. This is basically a 555 timer IC with a half bridge driver circuit, high voltage driver circuit built in, which drives these two mosfets here in a voltage doubler circuit. Charges this capacitor, which then doubles up its voltage into this reservoir capacitor here, and then we have a BCM Fooler resistors, the 10 resistors. Now I've used 0.1% tolerance resistors here, and I've just checked the voltages those. That's very good. So with an input voltage of 100 into this system here, we're getting 150 out here. This is just an adjustment pot at the end here, 100k. I'm still not 100% happy with the values yet. I just need to do a little bit more tweaking, but the circuit is working. It's on the bench. That's a good step. This is rated up to 600 volts. And I just need to, these are rated to 400 volts, the MOSFETs, and I just need to look at the values of these, maybe try and get some slightly higher values for the capacitors. I did have an electrolytic in here first, but that got very hot and didn't like it at all. The frequency is about 10 kilohertz for the switching. That was probably just a bit too high, and so I've replaced it with a metal film resistor, polyester capacitor 0.1, so that charges up quite quickly, and it all seems to respond quite correctly. So basically we just need a bit more tweaking with the values. I might need some slightly higher rated voltage. This is a 350 volt electrolytic. Unfortunately I don't know what that is, because that's all I had in my box, so I'll need to get a suitably rated capacitor for that, and probably this one as well. This one is also across the supply. So yeah, so there's a few little tweaks to do, but that's working at the moment at 100. I have tweaked it up to 150 and it was working. What you've got to be aware of is obviously when the car is, if the battery is disconnected, well, maybe if we're going to connect this to the battery anyway, so it probably would never be in that scenario. But if you imagine the battery wasn't connected and this circuit was subjected to the full voltage from the IMA motor system, then obviously it would be generating, if we were inputting 300 volts into this, it would be outputting 600, would be well over the ratings of the various components here. But as this is going to be connected directly to the switchboard onto the positive and negative battery terminals, that probably wouldn't, that scenario should never occur. Well, this is a fuse. This is just a 1 amp DC rated fuse, just to protect the circuit. And also what I would suggest is that it draws 5 milliamps, does this circuit, when it's operating from the high voltage battery, and it's all powered from the high voltage batteries. There's no low voltage side to worry about, so this is good. So obviously it's all isolated, and it's all going to be high side. So what we could do is what I did on my previous BCM Fooler, because you don't want this running all the time, permanently connected to the battery, because it's obviously a 5 milliamp parasitic load. You only want it on when the ignition's on. So basically what I'm going to do here is you'll put a 12 volt driven relay in this positive feed wire from the ignition. That's what I did on my old BCM Fooler. In fact, I've got that over here. This was one of the cars I used before, and you'll see there's a 12 volt relay. And basically it just disconnects the high voltage from the little circuit when the ignition is off. So that's all that needs to be added to this, really. So there we are. So that's the high voltage circuit. I need to order a few more parts, do a little bit more tweaking, and then I think it'll be ready to test probably early next week with a bit of luck. This is the rat's nest LTO cells connectors, BMS connectors, and my prototype CAN bus OBD2 CNC. So I'm going to get that resurrected over the weekend and get that sorted out and ready to wire up to my 4 BMS boards on the blocks I'll be using.